In manufacturing today, you must realize whether you live in Galesburg, Illinois, or Monmouth, or Dallas, Texas, or Los Angeles, you compete on a global basis every day with the supply chain. And the only way that we can compete with some of these countries, China being one, India is another, is in the labor cost. And you beat this game by technology and being able to build faster, build better, and more efficiently. And that's why we're in the development business doing what we're doing.
Hey, what's going on, everyone? It's the Talk About It podcast. I'm Lauren Fulmer.
I'm Victor Dantas.
And we have another fun episode here today, joined by Ray Whitehead with the Jupiter Machine Tool. Ray, how are you?
I'm great. Thanks for having me.
Good.
Thank you.
Really appreciate you coming and sharing kind of your journey and a little bit more about Jupiter. Why don't you start off, just tell us a little bit about yourself, Ray?
Well, I was born and raised on a cattle ranch in Texas. I went to Texas University. Sadly, I was only there for 6 months. I'm old enough that they dropped the college deferment for the lottery and had a lottery for the draft. My number was 2 in the entire United States. So imagine that, a national lottery and you're number 2. I haven't won a lottery since. So I spent 10 years active duty in the United States Air Force. I got my BSEE as an extension from the U.S. And then when I left there, I began working with General Dynamics. The reason for that was I had a lot of experience with tactical radar systems, of the A-10 tactical fighter, specifically fire control radar systems and the GAU-8 Gatling gun. That led me to go to work for General Dynamics, and that's because the Phalanx gun system that protects ships uses the same Gatling gun itself. And here's where I say never, because you might be surprised what you're doing next year. I started riding Harleys. I fell in love with it, and I became director of manufacturing of American Eagle Motorcycle Company. So I developed several engines, and some years later, these folks wanted to move back to Southern California. My wife is from San Francisco. Texas cowboy meets San Francisco gal. And so we moved up to Silicon Valley, and there I took over a company, Accurate Technologies. There I designed and built most of all the parts in concert with Fox Shocks, Fox Racing. And that's where the story takes. I got this great idea to start my own business. That was almost 27 years ago.
So have you always had kind of interest in gear? You know, some would call it a gearhead or mechanics and stuff like that, or was that because of the military experience?
Well, I was raised on a ranch, and so that means you're working on tractors and water pumps and animals and cattle, all day long, every day.
Sure.
So I just grew up as always wondering, how does that work? So my degree is in electronics engineering. I've just spent the last 25 years between electronics and mechanics. In this case, we've evolved into the manufacturing and design of CNC machines themselves. But the one question you didn't ask is, how does someone with a background like this wind up in Galesburg, Illinois?
How?
Thank you. That is a 2-beer answer. The truth of it is, there's a company here called Heat and Control. Their headquarters is in Hayward, California. Their CEO called me in and asked me if I would be interested in looking at Galesburg. And I said, well, not really. I'm on the way to Texas. Finally, after 20 years of California, we're going home. So somehow we wound up here, only just to see what it looked like. And 3 or 4 trips later, I found myself here making 3 promises to my wife, who's from California. And she basically said, well, now, honey, it's not going to get too cold out there in Illinois, is it? I said, no, it's not bad. And that year we had a 100-year winter. She said, we just had a flood in California. She said, they're not going to flood anything, are they? That year we had a 100-year flood. The last thing that she would not tolerate was they don't have any tornadoes. That year here, they had a tornado that demolished the city over by Peoria. So I was like 0 for 3, and she looked at me not too long ago, and she said, just one more strike, bud, and we're going home. So that's how we kind of wound up here.
That's funny. And what did she think of it, Midwest?
Well, I think the Midwest is the best kept secret in the United States. I think the people are very kind, very willing to work. I describe it this way simply. Here in the winter, if you slide off the road or something goes wrong, someone will stop and help you. In California, the only way you're going to get any help is that AAA phone call. Other than that, that's what happens. And that's just how the people are. So we found home here in Galesburg. We do a lot of activities with the high schools, with Galesburg vocational technology centers. We put in the first CNC machines that they had here in the history, and we began teaching class. Actually, my son had to teach class for a year to really get that seed planted and get the activity going.
And that's at the high school level?
It is at the high school level
That's
here at
amazing.
Galesburg. You may not know, but the Galesburg Area Vocational Technology Center actually services, I believe it's now up to 8 high schools, of which students from Monmouth High School is also attending. So these classes grew from 6 to now about 270.
Wow.
And I will say that when it comes to manufacturing of sorts, the first class I was in that I spoke with at Galesburg High School had only 7 students. 6 were guys and 1 was a gal. And at the end of that discussion, I simply asked a question of, are there any questions? I've never heard boys be so, I have 2 boys myself and they're not quiet, not ever. These guys, you could have heard a pin drop, but this one gal raised her hand and the question was, is there a place for a woman in manufacturing today? Something inside me think, are you serious? What kind of question is that? Of course there's a place for women in manufacturing. Why would you even say that? So I kind of stumbled through the answer, which some of the best leaders I've seen in the manufacturing business were women. Denise lives right here in Galesburg. She is a director of heating control. There's 2 gals up in Traverse City, Michigan, Cone Drives. That's a 100-year-old manufacturing company. 2 ladies work up there. One's director of manufacturing, the other's director of quality control. I call them the Twisted Sisters because they're really cool, but they really work hard. They're just amazing people. So the manufacturing business, there's oftentimes this stigma making people think it's just a male-generated historically industry, but that's just not true at all.
Mm-hmm. What's the workforce like in that industry right now? Is there older traditional employees are older? Are they younger? Or a good mix? What's that look like right now?
That question's regional. What happens is that it's not just the region; it's the actual industry itself you're serving. If you're in the advanced aerospace manufacturing business or advanced medical, you tend to see a lot more older folks in that business. In this case, in California, you see a lot of guys in their 50s, 60s. That's what you see in aerospace. Here, we have in the Midwest, where we're from, there is aerospace activity, but really this is about ag, construction, and by that I mean John Deere, Caterpillar, Case, Komatsu, and so on. And what we're used to is, Intel, Signetics. I built a lot of silicone loaders for semiconductor manufacturers, for example. The actual product you're building, it's very interesting to see how it changes from one location in the United States to another. We have a facility in Huntsville, Alabama, for example, and that facility is just absolutely surrounded by high technology companies. Blue Origin, SpaceX, McDonnell Douglas, Lockheed Martin, and so on and so forth. And so the industry grows in a tech way at a very advanced rate.
Mm-hmm. Ray, how was the early stages of Jupiter? Like, what type of product you guys started making, and your clients? Like, how was it the very beginning?
I guess to understand how it was in the beginning was, why do we have Jupiter?
Mm-hmm.
I came here with a company called Pegasus Manufacturer that's in the manufacturing business. Being a small business, one of the most expensive part of a business like that, it's a brick and mortar business. Unlike some businesses like software and things like that, they tend to be service oriented. But the computer numerically controlled business of CNC manufacturing is heavily invested in CNC machines. One of the problems you have with CNC machines in Galesburg is that I quickly learned that most things in this state are in Chicago, and we're part of what's called...
It's all good.
Yeah.
By the way, I guess they're looking for me. Sorry, I thought I had that thing turned off.
You're fine.
So I quickly learned what downstate meant. I had no idea what that meant. What it means to us is that we're about 2.5 to 3 hours away from most people that can service a CNC machine. So we went out and bought a CNC service company first, and that was the creation of Jupiter Machine Tool. So the service we did included all companies of all brands. Caterpillar, Case, Cat, Komatsu, the United States Air Force, and so on. It had been around, the company was called Dartech. It had been around for about 20 years or so, and it was a spinoff from Advanced Technical Services there in Peoria. And that was a spinoff from Caterpillar. About 20 years ago, Cat had a group of people they put together as an advanced manufacturing team that consisted of CNC machines, service, design, that kind of thing. And then Cat decided to divest themselves of that, and over time they created a separate company. So most of these guys that we hired came from ATS. So they had a lot of experience, and we were able to do business on a national basis with all brands of CNC machines. And the reason I felt so strongly about that is service today, whether it's your automobile or your dishwasher, it seems like we don't have good service in the United States. I mean, there are those, you find a really good mechanic or a really good guy to work on your house, whatever, those people are like gold. And so we really wanted to provide a good customer experience and be able to address their solutions, don't make excuses, and so that's how we got into it. The next step was the machines themselves are expensive, so the best way to get into that business is to own a machine company that designs and builds CNC machines. You can see the logic of how this works. So we started there, and quite frankly, we started selling machines that were built in China. The company was called SMTCL. It stands for Shanying Machine Tool Service. That was it. So the issue there was quality was okay once you got the machines running, but there was no service and no warranty capability. So we got frustrated with that, and we created our own company, Jupiter Machine Tool. And we selected it because it is the name of a planet, and that word Jupiter is not translatable on a global basis. It's pronounced Jupiter in Chinese or Indian or anything else. That was the impetus for it.
And then, so these, like you brought these in today, these are what you're making through Pegasus?
No.
Or
What happens is these two companies, I don't mean to be confusing to people, but what you have here in the simplest form, you have a company that designs, engineers, and services all kinds of CNC machines, automation, robots, and so on. On the other hand, Jupiter or Pegasus Machine Tool is a manufacturing company that uses CNC machines. So Jupiter designs and builds them, Pegasus uses them. The relationship between the two companies is really straightforward in the sense that Jupiter has designed and built some of the best, absolute best, most accurate machines on the planet. And that is just what the goal was, and we've been able to do that. The issue there is when you're an unknown brand, to get people to buy it, they don't know who you are, and one of the first things they want to do is, where can I go and see the machines run? Well, if you've got machines in Lockheed or Boeing or Deere or Cat, these companies will not let outside people in the building just to watch the machine run. So Pegasus happens to be on the same street with Jupiter, and so the customer is able to go down there and see it. Conversely, if, like, for example, Jupiter itself is certified to a number of these criterias, but Pegasus is a defense contractor. It's certified to the highest levels of quality control, starting with ISO 9000:2015, going to AS 9100D, that stands for Defense Aircraft, now being involved with 13485, which is a very difficult standard, which is medical. So Jupiter supports Pegasus manufacturers. It's certified to ITAR, JCP. All of these certs add up to we're doing business at Pegasus at a very high level with very high quality, and we have a lot of these credentials that open the door for us so we can have the opportunity to work with these companies.
Okay. What are some of these things here? What is that one used for?
Well, okay, there's two or three things here. These parts here are 3D printed. This part is a machine part. And this is part of the heat and control fastback system. It actually drives, this big gear drives parts, and it actually conveys potato chips from a potato chip fryer, ultimately to be bagged. So when you open your bag of potato chips and you find ranch dressing or you find jalapeno, any of that stuff, Heat and Control is building that system that does that, and Pegasus here in Galesburg builds components and pieces for the heat and control systems. On the other hand, when you move fast forward into advanced technology, these parts here, as you can see, are very different. These are not just machine parts. Most machine parts are made of solid metal, like this piece here. This would be a solid round part of metal, and then you're machining all this out of it. And today, what we're working on and developing is 3D metal printing. It's called wire laser metal deposition. And the idea here is that we are printing this part, we're only applying 20 thousandths on the surface more than we need. Let me put this in financial terms for you. This is Inconel. Most people are familiar with mild steel, perhaps aluminum, things like that. There are a number of reactive materials that are exotic in aerospace. This is one. This is Inconel. The raw material for this, to build this part, as you can see, it's about 5 1/4 in OD, outside diameter, costs $400. If we print this part, the material cost is $26, as an example. This is exactly why we are spending a lot of time and energy building machines that now we have 3 categories. Standalone printers, of which that we buy from a company in Spain called Meltio. Hybrid machines that we design and build. It prints like plastic printers. You've seen them, right? Mm-hmm. Except these machines print metal. So you print it and now we machine it. To make a long story short, you take a part like this. This is an aerospace quality part. It goes in a part of a missile head, to be honest. That's what it does. So we're able to build parts faster, less expensive, and better by using advanced tomorrow's technology. This is a good example. This part here, this is also a 3D printed part, except it's a hybrid. The shaft was actually machined with a lathe. It's steel, 4140 steel. This auger was actually printed on it and not machined because we wanted to do it for a demonstration. Ordinarily, a part like that would be really big and you would machine all of this away. So like augers for corn bins, augers for grain, augers for any kind that you can possibly manage, oils, materials, water. Any of those kinds of things, we can build this much faster and better, saving a lot of money. And the whole idea here, why are we doing all of this? Because in manufacturing today, you must realize whether you live in Galesburg, Illinois, or Monmouth, or Dallas, Texas, or Los Angeles, you compete on a global basis every day with the supply chain. And the only way that we can compete with some of these countries, China being one, India is another, is in the labor cost. And you beat this game by technology and being able to build faster, build better, and more efficiently. And that's why we're in the development business doing what we're doing.
Yeah.
How long does a CNC machine takes to make one of those?
This prints in about 45 minutes.
Okay.
The print time, for example, this part right here, from billet takes about, to machine it, probably about an hour and a half, 2 hours. There's some really, if you look, there's some really fine little,
It's very detailed.
details in that. Those all have functions. The back of that part, by the way, if you want to show your folks, is you can see the print, but we didn't machine it for the sole purpose of showing you what does the print look like before you machine it. Mm-hmm. So that's what the part actually looks like. So the thought about this is that it allows us to build these better parts at a lesser cost and then be competitive on a global basis.
Mm-hmm. One question I would ask, and even just for our listeners, you hear CNC machine, you're very deep in the industry, many are not, but I've heard CNC before. When in a nutshell, what is CNC? What is that? What's taking place?
First, CNC stands for computer numerically controlled. So this goes back. In fact, funny you should ask. I was just looking at the history this morning because I was doing a thing, preparing to do a presentation with the state of Illinois to reshore the manufacture of these machines. So let's start with the basics. All of us have seen our fathers and grandfathers probably on a farm or someplace that starts with a drill press. Then you go from that to a Bridgeport. That's a drill press that has a table move back and forth. Then you get to a lathe. It turns and you turn like wooden legs for tabletops like this. So a computer numerically machine essentially combines all of these features and with a CNC control, then controls the motion of all of that. So it becomes automatic. And so we're able to machine parts without touching them. We can actually now today run lights out in a continuous basis. So these come in a number of areas: vertical machines, horizontal machines, and lathes.
And then how many, I assume, can one person run the machine? Or does it run automatically nowadays?
No, the machine has to be programmed and set up. The people that set it up, you're applying a tool holder with tools, be it an end mill or a drill or something like that. So for example, if you're going to actually drill a hole in this part, you need a drill, right? Mm-hmm. Just like in your DeWalt, except this is accurate to within 2 microns. That's about the third of the diameter of the smallest single hair on your head, to give you an idea. So these various tools are loaded in the machine, and the machine calls them up, it drills it, and then it cuts in the end mill, it changes tools automatically, and so on. We could probably give you some videos of those machines running if you like. Perhaps you could put it here. I don't know.
Yeah.
For to make this, for example, is there anything that's manually done after the machine finishes making it?
No.
It gets out of the machine already like that, ready to be sent to your.
No.
Okay.
What happens is that you can machine parts, but some parts have to be plated or coated somehow. So you see a lot of steel, you coat that so it doesn't rust, right? Aluminum, you anodize it. So there's varying external parts that you plate, coat, finish to prevent rusting, increase strength. The parts can also be heat treated, or they can be annealed, which means it makes the material harder. There's a number of outside processes that we can apply based on the requirement of that particular part. But here's the cool thing. When it comes to this, guys, your imagination is all that limits what we build here. We can take a robotics application and move the robot while it prints, and Boeing's doing this now. They're prototyping building an entire aircraft fuselage in one part, no welding. We're looking at, if you look at some of our cases, like an exhaust manifold for hot rods, there's none of that welding and bending. We can print that in one piece.
Wow.
We're
So
now
size doesn't even matter.
That doesn't matter, because you can move the robot and it keeps printing. You could run it for 10 miles long and it'd be that long.
Wow.
So on the other side, though, for parts you can hold in your hand, parts that go in your hot rods or your cars or your combines, any of that stuff, these typically are limited to the work holding, the size of the CNC machine that they're in. Bigger part, bigger machine, basically. So I'd like to tell you our story about education here. The Monmouth is part of that story, and so is Galesburg. What happened to us is, you ask about how did we grow once we were here, and the labor pool is the challenging part of this. And what we found here is no matter how we tried to recruit people to Galesburg, quite frankly, we had a very difficult time to do it, to get them to move from Dallas, Texas, or LA, or North Carolina, any of those places. So finally, after a while, we got involved with Galesburg High School with Jeff Houston and Ralph Grimm, the principal, and at that time, the superintendent. And we said, look, we need to do something. So we at Galesburg, we put in a Votech little room. We brought in a CNC machine, and we donated it to the school. And much to my shockness was the fact that no one had ever done that before. And we began the vocational technology training. The history of, this is interesting, the history of Galesburg is literally founded on manufacturing. If you go look back in history, you'll see that years ago, that in Galesburg, they used to build steam engine cars in Galesburg. And then, of course, there was the pianos that were built. And then you get to more current times that everyone, when I moved here, talks about OMC, Maytag, Butler Buildings, all these companies left. So what we set out to do is to create a labor pool that really trains these young people so that they have an opportunity to have really great high-paying jobs once they're educated, and they go through, in this case, they go through high school. There's a 2-year course they can attend at Sandburg College for CNC printing, CNC machining, and so on, just like welding. And so once they're finished, we're creating that labor pool, and the technology is coming here to Galesburg. The next step beyond what we're talking about is manufacturing CNC machines here. You see, the state of Illinois, this is the strange thing, the irony of it all. Years ago, within the state of Illinois, in the 40s, 50s, and 60s, in this state, they designed and built a lot of these CNC machines here in the state. But long about the 50s and 60s, we started to offshore our manufacturing. We were looking for cheaper labor elsewhere in the world. So today, here in Illinois, there's very little of that other than just custom machines. So we are preparing to open up facilities here and start for the first time build production CNC machines in Galesburg. And that is now going up to the deputy governor, for Mr. Andy Menard, who works for Governor Pritzker. He's in charge of economic development and commerce in this state. So that's being reviewed because it's part of the way to bring manufacturing back to the entire state of Illinois. Because when we look at our buildings in Alabama compared to here, the manufacturers here have been leaving and going to anywhere between, if you draw a line between southern Texas to here and east to the ocean, everything in that block to the southeast, North and South Carolina, Kentucky. Kentucky has, Toyota has their largest assembly plant in the world in Kentucky. Mm-hmm. You've got Honda in Galesburg, excuse me, in Huntsville. So all of this has been going on, and much because of that, the educational workforce has not been developed here the way they are in those states. And that difference is very pronounced. I was in a junior college the other day in Alabama where they take the kids, and I don't know what their criteria is, but when they graduate from the 10th grade, they move them to community college. And so in effect, they spent the 11th and 12th grades there, and it's a dual credit approach, and the next 2 years getting their associate's degree, all of which designed to teach you how to run, set up, design, build parts, and run CNC machines. And as well, robots. Mm-hmm. Robots is the next step for automation, reducing labor. So what you see is a very robust culture and a very demanding labor market. Here, we could do the same thing, but we've got to understand how to get back in business. And that business is the business of manufacturing.
Yeah. When I've always said, I think in our, regardless of the industry, you know, our work staff, and not just here locally, I mean, really across the nation, I believe our kind of bar of our employees has gone down a bit compared to where it's been in the past. But I do believe, like, so that's a great idea, in my opinion, of like finding a way to strengthen that workforce, to also get young adults. I mean, a lot of young adults are getting out of high school. We have maybe an idea of what we want to do, but maybe not necessarily passionate about something, or not even know what options are out there. So to have a role in that, you know,
to learn those skills,
15, 16, 17, and 18-year-old, and just kind of at least letting them see something like that firsthand, it's a pretty great idea. Mm-hmm. I truly believe that.
Well, our doors are always open. If you've got kids that want to do a tour or anything like that, whether it be the local church or whether it's high schools or grade schools, we have kids that come over from Pekin, and we have to cater lunch because they're so far away from the school. They've got a requirement they have to eat at lunchtime, right? Mm-hmm. So we actually cater that and show these kids around. And I'm telling you, when you think that you can't get kids interested in manufacturing, you're wrong. We've got a lot of people working for us that came out of, now they're coming out of Western, University of Illinois, Iowa, and so on and so forth. We're beginning to draw the interest of those folks here, mm-hmm. as well as our own people. Because this stuff is really cool, man. This is not boring stuff. Yeah. These machines are cool. What we build is awesome. On any one day, we build parts right now for the Da Vinci robotic surgical system itself for Silicon Valley. That is a robotic system that's doing surgery on your mom. That's a pretty serious subject. So we build those kind of parts. We build parts for Springfield Armory. We build parts for the United States Air Force. We build parts for heat and control. What happens with us as a contract manufacturer, we have a very high technical bar that we try to look for, but it also means our people are trained very differently than factory workers. For example, if you work in a factory, you highly likely in production lines, you may be machining the same part or making the same item for a number of years, a long time. Mm-hmm. And I'll admit, that gets to be somewhat troublesome as far as what you're doing tomorrow morning. Here, they see so much of the change in technology. When you walk in our building and look at the range of the kinds of tech machines we have, they look like Boeing or Lockheed. In some cases, we have them, some they don't, because we're servicing those companies. We are here to grow. And so that's why I'm at this podcast, to be very honest. I'm just trying to visit with you guys. You're asking, how did we get here? And what are we doing? And now we're part of the family, and we're trying to grow here locally.
Yeah.
Ray, as artificial intelligence, we see that's developing a lot in a lot of different industries. How do you see that in the CNC industry and manufacturing?
There's no question that AI itself is a big deal for a lot of reasons. But AI itself also creates, and I'll ask your question, but first I'll answer a different question. it also generates a lot of opportunity that we don't think of. And part of that is what drives AI, very large microprocessors, they create a lot of heat. When you have a lot of heat, and I have experience with this in electronics, then you need some way to transfer the heat from these microprocessors, right? Normally that's done with a heat sink in cold air. Here, with 3D metal printing, we can actually print the components that with hollow passageways in them that allows us to pump liquid nitrogen through there, and we can control these faster, cool off this, so the density of microprocessors per square foot can be dramatically increased because of that. This is an example of that kind of technology. In terms of what we're doing, how we're building the AI set itself, this will come into manufacturing for programming at some point. They're starting to just put their toes in that, so to speak. There's still a question of, with any computer system, it's not any better than the input data that you start with. Garbage in, garbage out. From things like ChatGPT and those kinds of things, it's very interesting to see how people use that. I think it helps things, but there's a downside to all that in my mind. I guess you could say I'm kind of an old school guy. I was trained in science, mathematics, manufacturing, and I was riding a horse on a cattle ranch. So if you're not careful, you can step over education to the point that you start skipping some of the infrastructure of what you're teaching, and then they rely on this to the point that they really don't know how to do what they should do or need to do if that's not present. That's a concern in my mind. Maybe that's an old man's concern. But on the other hand, I see it. And so what do? I see it with just the car. Take your truck. When you take it in somewhere for service, they're going to plug it into a computer. And when these guys look at that error code, if they don't know what it is or how to fix it once they've changed those parts out, now what do? Someone has to have that expertise to troubleshoot it, and that someone is where the labor pool comes in. AI as an overall concept, for example, in advertising, keywords, you guys are in that business. You can see the power of it. It's pretty obvious. You're getting a lot more bang for your buck for a lot less labor is the bottom line, and it's pretty cool. So I think that's yet to be seen, but I think there's a dark side to some of that if you're not careful.
That makes sense. Have you used ChatGPT before?
Of course. How do you think I respond to your emails?
That's good. I just used it yesterday for the very first time.
Yeah.
Really?
Truly, yesterday for the very first time ever. I Googled it and just kind of started fiddling to see like how it works and what it does. But yeah,
it does. To me, the most impressive thing is, of course, Google. Before any search engine, they would get information from the internet to answer your question.
Sure.
Now, what AI is doing, what ChatGPT does, is it started to think, machine learning, thinking for you, get all the information, be critical, think, and give you the best answer, based on
all of what it gets.
Yes.
Yeah.
That's the most impressive thing,
And how fast.
Yes.
Right?
It is. We did this as an exercise the other day. We started talking to it and asked it, how do you think we should design and build this part? This thing starts to spit out some stuff that was pretty interesting, actually. I was surprised. It wasn't exactly perfect, but it was near enough as a start. It's pretty interesting.
Yeah.
But the question is, where does that take us? In our case, with 3D metal printing parts, we're able to now, in theory, supply enough print capability to machines fast enough, we may be able to eliminate inventory someday. In other words, this is almost George Jetson or Starship Enterprise stuff. It means you walk over to a console, press the button, and tell it to print a part to a dozer or something, or a spaceship. Or, by the way, when you're on Mars, you're going to need some parts you're going to have to make while you're there. So all of those things can be done, including body implant parts. Right now, in 3D printing, we're able to print and make material out of multiple kinds of metal. In the case of your shoulder, these parts are printed typically with titanium. In order to cut down staph infection, if you can add copper, which we're able to do, you can reduce staph infection by 87%. In other words, the world is becoming way more opportunistic. We have more opportunities than we've ever had to build and design things we've never either built or designed before. And for that reason, you may have noticed I'm not 20 anymore. But I often get the question, when are you going to retire? And I have two answers to that. My first one is, I'm still trying to figure out what I want to be when I grow up. My next question is, I don't plan to retire because I'm having a good time of new challenges and learning new things every day.
Mm-hmm.
And that's what keeps me getting out of bed and really being charged up when I get to work every single day.
Well, good for you. I try to implement a good little daily routine to give me that same sort of energy. And so for you, I mean, to still maintain that attitude, I know a lot of your peers, like you get that's the reason you get asked that question. A lot of your peers are already counting down their days. I got 13 more days until I'm hanging it up here. You know, you probably heard 100 friends say that. But,
or more.
Yeah.
But there's a trend in my 100 friends. Here's the story that I see. Maybe I shouldn't say this, but hey,
we won't tell them.
I'm going right on with the podcast theory here, guys. And that is the trend is kind of true. Once they retire, oftentimes they do want a few things for a few years. One is they want to travel, so they start traveling because they couldn't do it, right? Or they want to play golf all the time, or they want to go fishing all the time, or whatever it happens to be. After about 3 years of that, they don't really have a reason to get out of bed. I mean, when they got grandkids and they're running around, that's really great, but it's not the same thing. And so, as they say, a body in motion stays in motion. And so that's kind of the way I look at life.
Mm-hmm.
I mean, I'm here, I'll probably ask the preacher of the day that they're going to plant me, hey, can you give me another 10 minutes? I got to ship one more part.
Hey, what do you see in this industry in the next? It's come a long way. What do you see as it continues to evolve in the next 5-10 years? Anything drastically different, or what's your projections on some of that?
I mean, I would have to think it's going to be dramatically different for some of the reasons I just stated.
Yeah,
we're no longer, for example, when you machine a part, and you've got a truck that shows up with a load of steel. It's either round or it's square or it's rectangular in shape. You saw all that up before you start. Here, we can skip all that. We just start now with a roll of wire in 30 different flavors. In other words, for those of you that know, 1018 steel, 1045, 4140. I can go down this metallurgical list for a while. Point is, we've never been able to do it before, and we couldn't commingle these parts, either in a forging or a casting, but we can now. For that reason, some of the stuff that we're going to be able to build with nuclear reactors, power generation, all these kinds of things are just off the chart, and they're absolutely capable of being done.
Good.
Yesterday's dreams are truly today's reality.
Mm-hmm. Mm-hmm. Well, Ray, I really love that. For one, just trying to strengthen the workforce within our community here, but also even bringing people from the outside area here. I'm sure you've lived in Texas and California. There's probably not many places you can get $150,000 homes around there like you can here in the Midwest.
You know what? You're absolutely correct. And that's one of the benefits here.
Yeah.
For sure.
No, I know. So I wish you the best of luck as you continue to not only grow your business, but also your workforce and strengthen our community here at the same time.
Well, you're very kind, and we're very lucky. Part of the way that you sell things today is through your websites, and we have a great company. I think they're called Clear Profit. They do a lot of that work for us. We appreciate it.
Yeah.
Thank you very much, Ray.
No.
You're welcome.
Victor, you do a good job too, my man. Well, thank you, Ray, for coming and joining us on the Talk About It podcast. I really do appreciate your time.
Yeah, totally my honor and pleasure.
Yeah.
Thank you.
Thank you very much, Ray.
Yeah. Guys, that's Ray Whitehead with the Jupiter machine tool.
And Pegasus.
And Pegasus,
yeah.
And then also while we're doing that, we got Clear Profit Victor Dantas here. And I'm Lauren Fulmer. Thanks for tuning in. Have a great rest of your day.
Thank you. See you guys next week.
Bye.
Thank you for watching this episode of the Talk About It podcast.
I'm Victor Dantas.
I'm Lauren Fulmer.
And we would encourage you guys to subscribe to the channel. And don't forget to hit the bell. It's going to be right below the video. So
Hit the bell.
So you know when the next episode is up. All
We
right?
appreciate all the support.
Thank you.